Hello, this is Mike from Fair Repair, and yeah, almost 4 weeks I released my latest video, so it has been a while, unfortunately. I feel really sorry for that. Yeah, what can I say about that? The usual excuses. I was very busy. Indeed, I was very busy with a few very hard repairs. This is one of these. We'll talk about this later. And yeah, some other things. I mean, let me try to show you. Where is desktop recording? 1 second. Yeah. So, what is that? What could this be? I have no idea what this could be. What do we have here? A repair request? Very interesting. Very interesting. So, enough about that. But there is something coming. Soon. Okay? Promised. So yeah, I was really busy with some things. The shop you've seen right now I've built by myself. With my limited programming skills. So it is not a one with star, but it will work. It will work for me and it will work for the customers, and this is the most important part. As soon as I have the feeling I need a more professional shop, when I will do it. Promised again. So yeah. I had a few hard repairs on my bench. This is a Microsoft Surface Book, and yeah, I had really a hard time with this one, but yeah, see yourself. Let's go. This is a Microsoft Surface Book 2. You can detach the tablet from the keyboard with one button press. And the good part about this device is the tablet part is still working, so we have no mess with removing the display and things like that. Sadly, we have some dents and scratches, but well, it is a really nice device. Look how big the screen is. It is a 15-inch screen. 14 or 15 inch, I don't know. It is really big and actually hard to hold it with only one hand. Although it is pretty lightweight. However, how can we shut it down? 1 second. Yeah. Good. This is a really nice and very expensive laptop. It comes with a dedicated graphics card in the keyboard part. And the issue with this one is, as soon as I connect the tablet to the keyboard, the whole device stops working. So we have obviously a fault with the GPU part here. And yeah, like it is always the case, here was already some mess done. The back cover was already opened. Not very nice, but well, this is with what we have to deal. And here we have the board. And as you can already notice, you really can't notice anything. So we have to pull the board out of the chassis, and yeah, when we'll take a closer look. What I can already notice is we have some slightly water damage here. Can we zoom a bit? Here in this area, maybe you can see that here. This looks like liquid damage, to be honest. And it was not mentioned at always, of course. Not mentioned history. Yeah, but let's see. We'll remove the board and start checking things. I don't know I've never tried to repair a device like that, which is actually separated in multiple parts, but I think we can figure out. Let's see. Okay, almost nothing to spot here. So what else? Wow. This is wow. Okay. Good. Here we go. So, having the signs of liquid damage in mind, I would say we'll perform a fast visual inspection under the microscope first. So let's see. Here. Here. Here also. Okay, so we found a suspicious area here, and maybe we have something underneath the heatsink. Let's try to identify the main power rail. This is the input line. This is the input line. Is good. This is the buck boost converter, also good. And the main power rail should start somewhere here, I would say. And it is good. What do we have here? Same. Okay, so something else probably. So what else do we have here? This looks all right. This looks okay. What do we have here? 53. This could be the memory for the GPU. And here 2.3, 0.9, 0.9, 0.9. So 3 phases for the core. NVVDD. When? A secondary phase. NVDDS. Then we have something here. Kilo ohms. Sounds about right, but why is it dead then? Why is it dead then? Probably needs a battery to work. Does it need a battery or what? This is connected like that. Okay. Let's perform a few measurements. Core is not up. This is not up. Main power rail. 11 volts. This sounds about right, finally. Here we have a 3.3 supply. Here we have another 3.3. Here we have a 5 volts. Nothing. Nothing. Okay. Now it's off. Okay. This is fine. But how can we test? How can we test this device? Okay, 1 second. Let me try something. Additionally, power from the charger. Still working. So I now will connect the tablet. Careful. Now. It's connected, no? And still responding. For some weird reason. So what? Doesn't it has a fault at all or what? Well, we have of course to clean the liquid mark, but right now it looks working. Oh no. Now again, full spin, fan spin. So what is the issue with this one? And that's it. And for some reason it makes some incredible noise with the fans. GPU is stone cold, of course. It doesn't get power at all. Yeah, now you can see something. Maybe. Okay, I don't know. I think I'll try to install drivers. And then we'll see. Give me a few minutes, okay? So, here we are again. And obviously, the drivers did not help at all. No change in behavior. So we have definitely a hardware fault here. Interesting is, in the meantime, the battery has drained, so it is empty, and the board is stone dead now. Stone dead and doesn't make anything anymore. Which means the DC in circuit is somehow not okay. We'll dig into that soon. Let me show you the behavior now. When I plug in the battery. And connect the charger. So nothing happens anymore. Fans not spinning, nothing. Stone dead. So I'm not sure with what we are dealing here right now, but it is something in the early sequence. What I can spot already is that I have voltage at the first MOSFET, 15 volts, and at the drain of the first MOSFET, it is a P channel. I don't have anything anymore. This is because the gate here, here's the gate. The gate has 15 volts. Remember, this is a P channel, and with 15 volts the voltage cannot pass. The voltage needs to be lower compared to source, and it is more or less the same. So the voltage cannot pass, and the reason is, where can I find it? I think here it is. The reason is here. Here I traced back the gate. And here we have something around 500 millivolts, 0.5 volts. So the gate of the MOSFET is not enabled at all. Same if I come with the USB-C charger. This board can be charged with USB-C. Here we go. And the USB-C charger is actually recognized with 20 volts. So the PD circuit is okay. But for some reason, the voltage will not be switched to the input of the charging circuit here. No voltage here. For the exact same reason. Here's a small switch which is supposed to switch the 20 volts from the port to the voltage in of the charging controller. And we don't have anything here. Same reason, the enable is missing. We have actually a 3.3 rail here. This is the LDO, a small power supply. And nothing else anymore. Only the voltage in, the 15 respectively 20 volts, and the LDO is always working. So when I remove the power and make a resistance measurement, for example at the enable, nothing to spot here, mega ohms. Alright. But if I place my probe to the LDO, not the LDO, here we have the LDO, and here we have a switch, and after the switch we measure only 550 ohms to ground. Let me plug the charger again. Here's a small switch. We have the input, 3.3, yeah, and then we have the output on the other side, which is also 3.3. This is just a small switch, which is supposed to switch the power to this controller here. 3.2, alright? And you know what? If I measure here resistance to ground, we get the same low 500 ohms on the 3.3 rail, which is, in my opinion, awfully low. So what do you think? Let us move under the microscope. So, and this is a small arm controller, which acts, besides other things, as the Super I/O, as the M controller, and is also responsible to switch the first MOSFETs on, which it doesn't do. Now we have the additional observation that the 3.3 rail measures low ohms. So I did of course some more checks to have some sort of confirmation, but unfortunately nothing turned out so far. So I really assume this little guy here is dead. Let's make a small experiment. So let's set up the PSU to 3.3. So, can you see anything? Yes. So here's our board. Maybe we'll, yeah, like that. Yeah, now you can spot something. So let me inject into this 3.3 rail with 500 ohms, all right? So power. So now look here. What do you think about that? It's not getting hot. It's not getting hot, but it is really getting warm compared to the board. 3, 4, 5 degrees Celsius more than the rest of the board. All right, and this is our controller here. Okay, so this should be confirmation enough for now. I need to source a replacement, and unfortunately I have no idea whether this will work, because it probably needs some sort of programming, but yeah, we will see. Okay, let's see you in a few days. Bye. So 10 days later, and my replacement has arrived. Maybe. It's the same model. M22J9 VDC. ON50M. Third row is probably lot code. However, I would say let's replace and see what happens, huh? Nothing to lose, I would say. Yeah, solder bolts underneath. Good, let's remove the controller. Tweezer is big enough? Yeah. Okay. So this was a mess. It was way harder to remove than expected. So next time we'll use the preheater. So sanity check. Here, no? So this was nothing. We still have the 570 ohms. So the truth is, I start having doubts about my diagnose, but what should we do now? We have to proceed, no? Just a bit. This should be enough. So what do you think? Like that maybe? Let's see. No. Few seconds more. I think it is done. So I think we could try to power it on, and if it doesn't solve the issue, well, when we have to start over, no? Then we have to start over. So, time of the truth. Let's grab the USB-C charger. Or you know what, let's grab the normal charger and see what happens. So we have power. Do we have power? Yes, we have power. Okay, so once again, 15 volts at in and 1.3 here. Yeah, well, this is a serious issue. So our replacement did not help at all. $20 volts, 0 amps. I took a short rest, you know, after a good rest everything is better, and it seems like this time it is. I've used the time to think about this board. So what do we have here? We have a board which is basically dead. Although there's no clear short circuit on any power rail. We have replaced the SAM, the ARM controller, and it didn't change anything. Also, the resistance of the 3.3 LDO has not changed after removing the presumed dead SAM. So I have to strongly assume the SAM, even the old one, is good. Maybe we have even to solder it back because of the programming. However, this is not important right now because although it is normally not my style, I've started around more or less randomly. And the first logical point where to start was the charging area, because we have also the battery not charging, although it is probably related to the SAM, which is not working. But what should we do? What should we do then? Should we deem it a no fix? Not yet. So let us take a look to the charging controller. 1 second. So here we have a nice BQ25700A, which is a charging controller used in a buck boost converter. Maybe I'm just thinking too complicated all the time, but this time I concentrated on the battery not charging. The DC in is jumpered, the first MOSFET is jumpered, so we have power at the board. And I started probing around. I took a look here, pin 1, which is V-bus. Oh, 1 second. Voltage mode. So V-bus. So we have 15 volts here. When we have ACN and ACP, which are also 15 volt. 15 and 14. Oh, now the SAM is getting hot. Ah, damn. Why? Now the SAM is dead. Ah. Let's move to the SAM. So what happened here? I have no idea. Here we have a hole. Here we have a hole now. Why? I don't get it. So what happened here? Where is the short? Here, on the 3.3 LDO. So now it is finally dead, my replacement. Here we have a hole, but it's not important right now. We'll replace it again. My concern was more the charging controller. Now we cannot check with voltages anymore, but I can tell we have here pin 12 and 14 and 13, which is data battery data line and battery clock line. On the data line we have nice kilo ohms, 2 kilo ohms, alright? And on the clock line we have around 19 ohms. And also I did not have voltage here. So, so this means it is injecting time right now, because we have a clear short. 2 volts should be a good setting. So plus minus. So, and here we have a corresponding resistor which draws 200 milliamps. So, and if we go close enough, we have this hot component and also another one here. So we have probably 2 dead components. So, and these components are U2608 and U2610. Let's open the schematics. So, and here we have 2 I/O expanders which are controlled by the SAM, and these data lines are directly connected with the SAM and the charging controller. This is all together. There are only 0 ohms resistors in between. So with a short at the clock line, the SAM cannot control anything anymore. He don't have control about the power enable, which controls our MOSFETs, our DC-in MOSFETs. Same for the VBUS, the USB-C input. This all cannot be controlled anymore by the SAM because of the short on this line, of the clock line. So now we have U2610, which is probably dead, so we need a replacement, and also here we have U2608, which also is connected to the clock line. And yeah, probably we have to replace it too, and for some reason it looks like it is programmed or something like that. I hope it is not the case, because I'm really done with all this programming and I don't like it, you know. So yeah, let's I would say we start with removing U2610 and see what happens with the resistance to ground. Alright? So we'll start with the SAM. It is shorted anyway. Good. So this was his SAM. Now the I/O expander. Good. All right. So this is the expander. And now we'll check resistance to ground again. Regardless whether the board is hot or not. And it is still 25. And here it is kilo ohms. Alright, so this one, this part here needs to be removed too. What a mess. What a mess. This board is a thermal nightmare. Let's raise the temperature to 500 because I really lose my patience now. Yeah, finally. It is not so thin, this board, but the thermal dissipation is simply enormous. So let's check the clock line again. Hopefully we did not miss anything. It's still 36 ohms, I can't believe. Okay, but now we have to remove the board from the preheater, because this is no fun anymore. So we have even more dead components. I can't believe. Can't believe, really. Okay. So I know from the board view that this is a clock line. Ooh, it's hot, still hot. This is the clock line. And it still measures 63 ohms to ground. I can't believe. And this line here is data. And here we have kilo ohms, alright? So we need to reach this value. 2.6 kilo ohms, plus minus. But here 36 is clearly too low. This is not okay, so we have to inject again. But first we have to wait till the board is cool. Is way more cool. So what else could be dead then? So board is cold enough. I would say it's time to inject again and see what is getting hot. The other chip, the other expander. Is it the other expander? U4102? No, it is not the other expander. U4102. Here, this is another weird component. I have no idea what it is. Comparator? What does it do? I have no idea. I have no idea. Max. What is it? SM bus 4-channel wide dynamic range power accumulator. Code optimization. Processor overhead. Evaluation kit. Oh. Current and voltage monitor. Oh. I don't think we can do that. Okay, let's go. Good. So next resistance to ground check. $55 ohms, I can't believe. Almost everything on this rail is dead. Come on. Come on. What happened, what happened, what happened? Everything on this rail is dead. How is this possible? Yeah, this is clearly pulled up from 3.3. So I don't make anything wrong if I inject there. Nothing wrong with that. But injecting made the situation worse for some reason. I did not understand, to be honest. Okay, then we'll move on with 55 ohms. All right, 55. Yeah, good. So what comes next? So consumption 100 milliamps right now. Okay. This is my small load switch. U2806. So the things are getting worse and worse. I don't know the reason, but it is how it is. So here somewhere, this one. But why? This? Moment. Pin 3 is ground, so this is ground, alright? Yeah. This is our enable mega ohms. And this is ground, pin 3. This is pin 1, but pin 1 is not connected. How can it be shorted then? This is my jumper from the VCC to the enable, and here everything is fine still. This is ground. I don't get it, to be honest. I don't get it. This is pin 1 and 3, and they are supposed to be not connected and ground. So why do we have a problem here then? So I just don't know how this could help our clock line. This is the question. Yeah, this was expected. It does nothing. It heats up for another reason. Let's proceed then and find something else. Probably not on this side. More likely on this side. So let's search for the next chip, and I think I've already found him. Look here. Weird, no? So this is U2304. Yeah, this fits. Here we have the clock going in. Good. This part has to be removed too. The small guy. Whoops. All right. All right. Part number 6. Okay. So next resistance measurement. Minus. And we have 57 ohms. I can't believe. I can't believe. What else? What else? Everything? Is everything dead on this rail? Here we go. Next attempt. 7 components removed. 7 components. And we have kilo ohms. 13 kilo ohms. 13 kilo ohms. Finally. Finally. Okay. Okay. And now we have to think about whether it is possible to replace these parts, whether some are maybe not necessary at all, and whether we can, with any luck, revive this board again. What a mess. I can't believe. Okay, I'll come back. So, time of the first truth, I would say. What we already know is that A, the GPU is probably not working. Too many parts related for the GPU to the GPU are missing. The battery is probably dead, so we left it out for this test. But I'm really curious whether by any chance the keyboard and the touchpad is already working just by replacing the ARM controller, the SAN. Let's see. So here's a tablet. So let's see what happens. Now. Oh, I hear something. I hear something. Okay. Slow charger, 1.8 amps. So it is. And the touchpad is working. I can't believe. Can you see that? No. Now you can see Now you can see the mouse, right? Let us write something. Update is working. Keyboard and trackpad are working, I can't believe. This is amazing. So we have already a somewhat usable system restored, which is great news actually. This is very good news. I was really afraid that we have still a somehow dead base here with these weird ICs missing. Okay, wonderful. Yeah. Oh, let's try the detach button. It's green and I feel something. Yeah, I can detach it. I can't believe. This is great. Okay, now I want the 100%. I see where I can find these ICs and when I want the GPU back. Alright, let's see. Hello! Another 3 days later and the parts from DGK have arrived. So we have 3 out of 5 missing components. 3 which are located in this direction, another component I have on a donor board, and the thermal sensor we just try to leave out because I did not find any replacement so far. So yeah, let's try without. Another interesting thing is, maybe you remember, I assumed the battery is dead, because as soon as the battery was connected, the charger went into protection and the USB-C charger was somehow stuck in a loop. Well, I managed to solve that, and unfortunately I did not record the troubleshooting, but I will explain what I did. First, let's plug the charger and see how nice it works right now. So 19 volt and charges with 1.7, 1.8 amps. Wonderful. So what happened is the following. You remember the problem at the clock rail, at the main clock rail, which connects to many components on this board. We had this problem with the 10 ohms short to ground, a partial short. We have solved that and the resistance was fine in high kilo ohms, all good. However, as soon as I apply power to the board, the main data line has 3.3 volts, but the main clock line still has a voltage drop 2.8 volts. So for this reason I assumed we still have a problem on this, and to come behind the fault actually needed a smart move. So I separated circuit after circuit from this line till only the charging controller was left. So when I replaced the charging controller and had the 3.3 volts back, wonderful. However, the board was still not charging. Still, the USB-C charger was still in a loop, and the main charger at least tried to charge the battery for, let's say, 2 seconds and then started over. So it charges when we had for 10 seconds or so nothing, and then the charger tried again. For this reason I've looked around the charging controller, and indeed I've checked the battery sensing lines, CSIN and CSIP. And on the sensing lines there are usually some low ohms resistors. Can be 2 ohms, 5 ohms, 10 ohms. In this case the resistors are supposed to measure 10 ohms internal resistance. And the first resistor measured 19 ohms, which was still somehow inconclusive, but the other resistor measured over 200 ohms, which actually results in a big voltage drop. So the CSIN and the CSIP pins got completely different voltage measurements because of this high difference. And for this reason, the battery was not charging. I've replaced the resistors with proper 10 ohms resistors, and now the board is charging 1.9 amps right now. Alright, good. Next step is to solder all these components. I would say I'll put the board on a preheater again to not have the punctual stress on just one point. So the heat is more spread, and I have not to use so much heat at one point. Yeah, let's try that, and yeah, when cross the fingers that the GPU will be alive again. I have no idea whether this will work because we have many components here which needs I2C communication, and yeah, seriously and honestly, I have no idea how this all works. No? I can just replace the parts and see what happens. Maybe we have luck, maybe not. Let's see. Now, see that? Okay. Good. Finally. Oh, look. So, I think we are done. We let the board cool down for a while. Yeah, and then we'll see whether the board still works at all. Maybe. Maybe not. Sorry, but no. No, it did not work. What happened is the following. I've played with the 1.8 volts buck converter and tried to manually enabling it because for some reason the enable was low all the time, although there was no short, and something must have went really wrong at this point, and the whole controller, the whole 1.8 volts controller shorted out between main power rail and the GPU. So like 13 volts went into the 1.8 volts rail, and yeah, this was instantly the end of the GPU. So there is no point to try to fix it anymore. I don't know the reason. Manually enabling the controller should not result in something like that, because there was no short. There was no short on the main power rail, and there was no short at the load side. I don't know what happened. Yeah, so we'll take it as is. This device is still working with the tablet and the keyboard. The only thing which is sad is that the dedicated GPU is not working. But well, it is still a very nice device. We can remove the tablet again. Yeah, now, okay. Now I have the tablet. I can remove it. I can put it back. And the best part is that mouse. Can you see the mouse? Maybe. Mouse and keyboard are actually working. Also the USB ports. Everything is working. Even the SD card reader is working. Everything is working except the dedicated GPU, and this time we leave it like that. I don't have a spare GTX 1060 laying around. Otherwise I even have tried this to replace it, but I don't have it, a non-working GTX 1060. So yeah, this is the end, and I'm still happy about that. Okay, good. So The next video should be also really nice. It's about a median eraser, which has a problem with the, beside other problems, it has a problem with the main VRM controller, the controller which powers up the rails for the CPU. And this will be very interesting because some sort of programming, of chip programming, will be involved to bring back the device back to life. Hopefully it will work. I have not finished the repair yet. I'm waiting for parts right now, but yeah, I hope it will be really interesting and really good. So yeah, as always, if you like my videos, I'm happy if you leave a like, a comment, or even subscribe to my channel. The tools I use are linked in the video description. Thank you for watching and see you next time. Bye!